Let's talk about problem number 2 in the homework for the section where we do Laplace transform. So if we look at this problem, it says, I give you a function which is tangent x. I want you to tell me whether the function is continuous or discontinuous. Or piecewise continuous. So basically, if you look up the graph of tangent function, what you are going to end up with is something looks like this. And it's the same structure repeated. Oh, sorry about that. And it's going to be going to positive and negative infinity at pi over 2 and negative pi over 2, which is not easy to understand because tangent is sine over cosine. So whenever your cosine function generates a value of 0, the tangent function is not defined. So that's why it has this behavior where it goes to positive or negative infinity around pi over 2 and negative pi over 2. And therefore, it's a periodic function because both sine and cosine function are periodic. So what you're going to get is it's going to be piecewise continuous because it's a lot of continuous function putting together. Each piece is continuous. So it's not continuous everywhere because there are clear differences. So it's not continuous. It's piecewise continuous, but it's from negative infinity to positive infinity. Therefore, this description is not accurate. So we would go ahead choose neither. This function is piecewise continuous from negative infinity to positive infinity. And is this function exponentially bounded? The definition of exponentially bounded we discussed in our class notes in the section which we talks about introduction to Laplace transform. I highly recommend you to go back to the notes. It's towards the end of the section. The naive way of understanding it of a function being exponentially bounded is basically the graph of the function. If we take the absolute value of it, is going to be always below the graph of exponential function. So for example, this is my axis. This is like my graph of e to the power of x for demonstration purpose. So if you have a function whose behavior is like this, right? So this function is as it goes towards infinity, you realize it's always going to be smaller. The function value is going to be smaller than the exponential function. So we say this function is exponentially bounded. Similarly, if you have your trig function, sine and cosine, which always stays between 0 and negative 1 and 1, it's always bounded by exponential functions. So that's the idea of exponentially bounded. Well, if you think about exponential function, its graph is going to be something looks like this as we move towards infinity. Well, you realize the tangent function is already approaching to infinity simply when it gets approached to pi over 2. Therefore, it will never be bounded by an exponential function because this goes up too quickly. So the answer for it is no, it is not exponentially bounded. And like I said, we define exponentially bounded at the end of the section where we introduce Laplace transform for the first time. So the reason we introduce Laplace transform exponentially bounded and everything in there is because we say if a function is piecewise continuous and it is exponentially bounded, then my function will have Laplace transform. But if it doesn't satisfy those two conditions, for this particular case, we can actually say, well, the Laplace transform does not exist. Okay, so it's not exponentially bounded, it's not piecewise continuous. This function does not have a Laplace transform that exists. So this is how we answer the question.